Hi everybody, this is going to be another Unit 4 video, and we're going to talk about dividing complex numbers. But before we do that, I want to talk about conjugates. Now, the two examples you see here are example of complex conjugates. Okay, 8 plus I times 8 minus I. Now, these conjugates, when multiplied together, result in a real number. And this is going to be really helpful for when we're dividing here in just a minute. Because when we multiply these complex conjugates, what happens is we're able to cancel out some terms. So you can see there those 8 i's are going to cancel. And the I squared can be replaced with -1. So we really just have 64 plus 1, which is 65. So when we multiply those complex conjugates together, we're going to get a real number. Okay, let's look at one more example. Okay, so you can see here that those middle terms are going to cancel out. Let's replace our I squared with a -1. So it's really 25 plus 16, which gives us 41. So this idea of a complex conjugate is going to come in handy when we go to divide some complex numbers here in just a moment. Now, let's start off with something a little simpler. Okay, in this case, we are dividing by not a complex number, but just an imaginary number. Okay, and that makes it a little simpler. We have to think, how can we get rid of that imaginary number in the denominator? Okay, we don't like imaginary numbers in the denominators. We will always want them to be in the numerator. Okay, so here's my thought. I know that if I multiply I by another I, I'm going to make an I squared that I could then replace with -1. So here's my strategy. I need to multiply my denominator by I. But if I'm going to do that, I need to also multiply my numerator by I. Because this right here is just equal to 1. We know multiplying something by 1 doesn't change its value, even though we're changing the structure here. So if I multiply by I over I, what happens is I get an imaginary number now in my numerator. That denominator has an I squared that I can replace with a -1 now. So my denominator becomes a +9, and I have simplified that expression. Okay? We don't like imaginary numbers to be in the denominator. We want to get them in the numerator, so this is a way to do that. Okay, the example here on the right is another example where we only have an imaginary number in the denominator. So we just need to multiply by I, but if we're going to do it in the denominator, we're going to also do it in the numerator. Now, we're going to have to be a little more careful here. I'm going to have to distribute the I to both terms inside. So the numerator is -8I minus 2I squared. My denominator now is 6I squared. And I have two places where I'm going to replace the I squared with a -1. So if I do that, I have -8I minus 2 times -1 over 6 times -1. So that becomes -8I plus 2 over -6. Okay, I'm going to reorder the numerator here so that it's 2 minus 8I divided by -6. And then I'm going to divide each term in the numerator by -6. So 2 divided by -6, I can reduce that to -1/3. -8I divided by -6 would turn into plus 4/3 I. And there I have it. So this is an example, two examples of dividing by an imaginary number. When we go to divide by a complex number, like we have here and here, it's going to be a little more complicated. I can't just multiply the numerator and denominator by I. I have to multiply the denominator by something that's going to make the denominator turn into a real number. Now, at the beginning of the video, we said complex conjugates, when multiplied together, turn into real numbers. So I'm going to multiply the denominator by its complex conjugate. 6 minus 2i, which will multiply the numerator by the same thing. So now you can see this division problem is really just a lot of multiplication and simplifying. The numerator and the denominator are going to need multiplied together here. So we're going to get 30i minus 10i squared over 36 minus 12i plus 12i minus 4i squared. Notice in the denominator, these are going to cancel. I can replace my I squareds with -1 now. So -10 times -1 will turn that into a plus 10. In my denominator, that -4 times -1 is going to turn into a plus 4. And we can take it a little further. I'm going to rearrange the order in the top and the numerator there. And then we want to reduce this. So I'm going to go ahead and divide 10 by 40 to get 1/4. Divide 30i by 40 to get 3/4 I. So you could write it like that, or it would also be okay if you wrote it like this. 1 plus 3i over 4. Either one of those would be okay. So let's look at one more example here. Right? Another example where we have a complex number in the denominator. So we need to multiply by the complex conjugate, which is 2 plus 4i. And we need to do the same thing to the numerator. So again, we have a lot of multiplying to do. We're going to get 2 plus 4i plus 16i plus 32i squared. In the denominator, 4 plus 8i minus 8i minus 16i squared. In the denominator, the 8i's are going to cancel. Let's go through and clean up some stuff here. So in the numerator, I'm going to combine those two middle terms. I'm going to replace the I squared with a -1. So that's going to make that -32. In the denominator, I'm going to replace I squared with -16. So now, this is really -30 plus 20i over 20. So if we divide, we could write this as -3/2 plus I, or we could write it as -3 plus I, or I'm sorry, plus 2i over 2. Either one of those would be okay. All right, guys, hopefully this video made sense. Let me know if you guys have any questions, and have a wonderful day.